Hello everyone. Welcome to day 1 of crash course. Today we will cover set theory. This is our disclaimer. So at first let's analyze analysis of set theory on JEE Mains paper. So for last 5 years, the chapter weight is for set is 2.55%. And if we do year-wise analysis, so in year 2024, total one question come from the chapter set on the topic Venn diagram, which cover the concept number of element and which is average type question. And year 2022, one question is coming from the topic subset based on the number of subset for the set. There is one question from difference of set in year 2021, and in year 2020, one question come from number of elements in different sets. Okay, that is your easy type. And in year 2019, the question come from subsets based on number of subsets of a set for a set of quantity n. Okay. So in today's lecture, at first we will discuss about set. What is the definition of set? And then we will discuss about types of sets. There is many kinds of set. Then we will discuss about Venn diagram. And at the last, we discuss about operation on set, means that if you have sets, then what operation can be performed between them. Okay, so let's now start study about sets. So if you want to define a set is well-defined class or collection of the object. So what is the meaning of well-defined? Well-defined means there should be no confusion in including or excluding any object. If you want to conclude any object to that set, there must be no confusion. For example, if you ask about your 3 favorite IPL teams, so there must be confusion because the answer is vary from person to person. But if I ask about how many vowels in the English alphabet, then the answer is A, E, I, O, U, because these are the vowels in the English alphabet, and this is well defined collection because everyone answer will be the same. So collection must be a well defined, then it is called a set. The set is usually denoted by capital letters. So capital letter A, B, C are used to denote sets, and to denote the elements of the set is a small letter A, B, C are used to denote the elements of the set. Okay. If A is an element of a set A, then we can write it as, the notation is A belongs to A. This notation is read as A belongs to A. And if A is not an element of a set A, then notation is this: A does not belongs to A. Here small a represent the element of set A and capital A denote the set A. Okay. So now we will study about the forms of set, how we can represent a set. So there are two methods for representing a set. The first one is roster form. So what is roster form? So roster form, a set is describing by listing element separated by commas with curly braces. For example, if we talk about the set of vowels of English alphabet, then the roster form is A, comma, E, comma, I, comma, O, comma, U. So this A, E, I, O, U are the elements for the set which are listing and separated by commas within this curly braces. So this form is a roster form. Second form is set builder form. So what is set builder form? So if you want to, if there is a set and we describe a property Px, which is possessed by all its element x, in such a case, the set is written as curly braces x colon Px is true. So here x is an element of a set if it satisfies the property Px. So if a set is represented in this form where Px is a property and x is an element of that set, then it is called set builder form. For example, there is a set P, that is your elements are 0, 1, 4, 9, 16, comma dot dot dot. This is your roster form. And if you want to represent in a set builder form, then it can be written as P is equal to x square. X belongs to z, integer. So here x square, that is x belongs to integer, is a property. Okay, and that is your set builder form. Okay, so there are two forms to representing a set. One is roster form and another one is set builder form. Now let's look at the types of set. So there are different types of set. The first one is null set. Okay, the set which contains no element at all is called the null set or empty set or void set. So if there is a set and it contains no element, then it is a null set. Okay, and this set is denoted by symbol phi or this open and close curly braces. That is the denotation of null set. And if a set contains a single element, there is only one element to that set, then it is called a singleton set. Okay, next type is finite set and infinite set. A set in which the process of counting of element definitely comes to an end. Okay, then it is called a finite set. For example, a set of vowels is a finite set, and if you take a set 1, 2, 3, 4, 5, then it is a finite set. Otherwise, it is an infinite set. For example, if you collect all the natural number, then it is not an finite, it is an infinite set. Okay. Now we are talking about equal sets. If we have two sets A and B, then they will be called equal sets only if every element of A is an element of B, and also every element of B also an element of A. So all the elements within them are exactly the same. Then we call set A and B are equal sets. Mathematically, we can represent it as A is equal to B if x belongs to A, then x belongs to B. Conversely, if x belongs to B, then x belongs to A. Okay, then we say A and B are equal sets. Next type is equivalent set. So what is equivalent set? Equivalent set are those sets in which the number of elements is the same, but the elements are not the same. Okay, so we are talking about the number of elements, not exactly the same elements. Okay, so if two sets A and B have the same number of element, then we call this set are equivalent sets. Next type is universal set. So universal set, that is denoted by capital U and is defined as a set that include all the sets within that context, then it is called a universal set. Okay. Now we define subset. So if A and B are two sets, okay, and if every element of A is an element of B, then A is called a subset of B. And if every element of B is an element of set A, then we call B is a subset of A. And how we denote this? We denote this it as A is a subset of B. So if we call A is a subset of B, then if a element X belongs to A, then it is also belongs to set B. Okay. Now, there is two types of subset. One is proper subset. So what is proper subset? So if A is a subset of B, and the second condition is A is not equal to B. First condition is A is subset of B, and second is A is not equal to B, then A is called proper subset of B, and it is noted by this, that is A is proper subset of B. Second one is improper subsets. So what is improper subsets? One important thing is that a null set phi, that set contains no element, is always a subset of every set. Okay, that is your improper subset, and every set is a subset of itself, that is phi is subset of A, and a set A is subset of itself, so A is subset of A. So these two subsets phi and A are called improper subsets of A. Okay. Now let's move forward. Now we are talking about power set. So what is power set? So let's consider S is any set, then the set of all the subsets of S. We create a new set, that is collection of all subset of S. Then this set, this collection is a set, and it is called power set of S. Okay, and it is denoted by capital PS, that is power set of set S. One important thing is power set of a given set is always a non-empty. Okay, and if A is any set and A has an element, then power set of A has to the power n elements. So that's how we can calculate the number of element in a power set of A if we know what is the number of element in set A. Okay, so power set is nothing but a collection. It is also on a set, and it is a collection of all the subsets of that set. So let's look an important note. The set phi, this curly braces and there is a phi, it is not a null set. Simply we can, if you write phi, then phi denote the null set. But if you write phi under the curly braces, then it is not a null set, but it is a set containing one element phi. So it is a singleton set. Okay. And whenever we have to show that two sets A and B are equal, then we show that A is a subset of B and B is a subset of A. So if we show that they are subset of each other, then we will say that A and B are equal. Okay. Now let's talk about cardinal number. What is cardinal number? So if we have a set A and set A has m element, then that number m is called cardinal number of set A. So cardinal number denote the number of element present in that set, and it is noted by small n A, that is number of element in set A. Thus NA is equal to m. Why? Because A has m element and m is the cardinal number of set A. Now we will talk about Venn diagram. So what is Venn diagram? It is also known Venn-Euler diagram. Okay, because of Venn-Euler, who was a scientist which explained this, who explained this method. So Venn-Euler diagram is a combination of rectangles and circles. Okay, so in Venn diagram, the universal set is represented by rectangular area. Rectangular region represent universal set. Okay, we know what is universal set, and set is represented by circle or some closed geometrical figure. So we can use circle or any other closed geometrical figure to represent set. So universal set is represented by a rectangular region, and a set is represented by circles and geometrical, any closed geometrical figure. So in the figure, this is the figure of Venn diagram, where this U is a universal set that is represented by this rectangular region. Okay, and A is a set of U, so that is represented by a circle. Okay, so universal set is the set that contains all the subsets. So if it in the context, so if we take A as a set, so each element of A must belongs to U. Okay, so now we talk about operation on sets. So first operation is union of sets. So if we have two sets A and B and we want to describe union, so union of set A and B is the set of all elements which are in set A or in B or in both A and B. So union of set A and B is another new set. And how it's formed? It's formed by the element of A and B both. Generally it is a we combining both the sets A and B by removing duplicates. So we write the elements that are common are written only once. Mathematically we can define this operation as, so U union B, this is your how we denote the union of A and B by the sign U. So A union B is equal to X. So X is an element of A union B if X is belongs to A or X is belongs to B. So A union B is a collection of all the elements from both set A and B without repetition. So if there is an element that belongs to both A and B, we write it only once in a set A union B. So this is your Venn diagram for A union B. This U represent, that is a rectangular region, is your universal set, and there is two circle A and B which also overlap. So overlap portion is represent A intersection B, and that element that comes in A and also in B, and this all set region is A union B. Next operation is intersection. So the intersection of A and B is a set of all those elements that belong to both A and B. Okay, so we can define it as A intersection B. That's how we denote the intersection of set A and B. So A intersection B is equal to the element X belongs to A intersection B if X belongs to A and X belongs to B. So for an element to belong in intersection, it must belongs to A and B both. So intersection is just a common elements that belongs to both in A and B. So we can represent it in a by Venn diagram. So U is your universal set, A and B is another two sets, that is a subset of U, and the intersection portion is just represented by the overlapping portion, which portion represent that these elements are those elements that belongs to A and B both. Okay. Now, if A intersection B is phi, it means if there is no element in the intersection, okay, then A and B are called disjoint set. Now we define complement of A. To define a complement of A, there must be a universal set. So let U be an universal set and A be a set such that A is subset of universal set. Then complement of A with respect to the universal set U, that is noted by A dash or A complement AC or A bar or U minus A. So these are the how we denote the complement of A, and the complement of set is defined as the set that contains all those elements of U that are not in A. Okay, so if there is an element that belongs to A, then it does not belong to A complement. So by Venn diagram we can picturize how the complement of A looks like. So there is a rectangular region, that is universal set, and this circle represent your set A, and outside the circle is your A complement. Okay, so A complement are the all the element that is that the element of set U that are not the element of set A, that is your complement of A. Okay, next operation is difference of sets. So we have two sets A and B, then A minus B means the set of all those elements of A which does not belongs to set B, that is your difference of set A minus B. So by mathematically we can express it as A minus B. So A minus B means X, an element, belongs to A minus B if X is an element of A, that is X is in A but not in B, that is your A minus B. What is B minus A? B minus A means X is in B but X is not in A, then it is B minus A. That's how we define difference for two sets. We can also picturize it by Venn diagram. So first figure represent A minus B. So there is U is universal set, A and B are two sets. So if we say the shaded region, these are the elements that belongs to A but does not belongs to B, then it is your A minus B. In a similar way, we can define B minus A. Okay. Now we define symmetric difference of sets A and B. Okay. So the symmetric difference is the set that containing all the elements of A minus B and B minus A. That is A minus B union B minus A. So if you want to find the symmetric difference of A and B, then at first calculate differences of set, that is A minus B and B minus A. And when we take union of A minus B and B minus A, we get the symmetric difference of A and B. And that's how we denote symmetric difference. So symmetric difference AB is equal to A minus B union B minus A. So by Venn diagram it can be represented as, this is your rectangular region is universal set and there is two sets A and B. So what is symmetric difference? Symmetric difference is just a union of differences of these both sets. So A minus B union B minus A. So if you take A union B and subtract the intersection part, A intersection B, then we get the symmetric difference of set A and B. Okay. Wait for a minute. Now we will do some question based on set. Okay. So we'll practice total 8 question from the topic set, and all the question are MCQ type. Okay. So let's look at the first question. So the first question state that we have a set Q, and which is a set The definition for the set is x belongs to Q if x is equal to 1 by y, where y is a natural number. Okay. Then, so we are given that element 0, 1, 2 and 2 by 3. And we are asked whether this element 0, 1, 2 and 2 by 3 are member of set Q or not. Okay. So what is the definition of Q? X belongs to Q if x is equal to 1 by y, where y is a natural number. And we have to check whether which of the element is belongs to Q. It is 0, 1, 2 or 2 by 3. Okay. So let's solve. So correct answer is option B. Let's look at the solution. So clearly, the value 1 by y can never be 0, 2 and 2 by 3. Why? Because this form of this is 1 by y, and as y is a natural number, so there is no natural number such that 1 by y can be 0 and it can be 2 or 2 by 3. Okay. But 1 by y can be 1 because there is a natural number 1. So if you write 1 by 1, that is equal to 1. Okay. So x equal to 1 is an element that satisfies the property of x is equal to 1 by y, where y is natural number. We can take y as 1 and 1 is a natural number. So we get 1. So 1 belongs to this set Q. So correct option is option B. That is, 1 is the element that belong to this set. We satisfy the property for that set. Okay. Next question is, this question is about power set. So we have a set A, and set A is the void set. Void set means null set, a set that has no element. So then what is the number of elements in power set of power set of power set of power set of A? Okay. So we have to calculate the cardinal number for this set, and the given options are 0, 1, 4 and 16. So how we can calculate the cardinal number for a power set? So we already know, if A is a set and A has total n elements, then number of element in power set is to the power n. So by using this formula, we can solve this problem. So let's look at the solution. Now, A is a void set. That means the set A has no element. So cardinal number for set A is 0. And we know that the number of element in power set for the set is to the power n. And here n is 0. So to the power 0. So 1. So number of element in power set of A is 1. And to calculate the number of element in power set of A. So now the number of element for power set of A is 1. So number of element for power set of A is to the power n, and here n is 1. So it becomes to the power 1 is 2. So number of element in power set of A is 2. To calculate the number of element in power set of A, as the number of element for power set of A is 2. So number of element in power set of A is 2 square, that is 4. In a similar way, we can calculate number of element in power set of A, and the power set of A is 4. So number is to the power 4, that is 16. So that's how we can calculate the number of elements in power set of A, that is 16. Okay. Let's move to the next question. So question number 3 is, we have given two sets. One set is set X and another is set Y. Set X has elements of the type 4 the power n minus 3 into n minus 1, where n is belongs to a natural number. And set Y is defined as 9 into n minus 1, where n is a natural number. Okay, so we need to find X union Y. Now I will give you an idea. First of all, the set X and Y are written in set builder form. We know the set can be represented in two forms, set builder form and roster form. So this is your set builder form. So at first, convert this set builder form to roster form. After that, we will take the union of these two sets. We get your answer. Given options are n, that is natural number, y minus x, difference of y minus x. It's again come x, or option D, y. So correct option is D. So let's check. So we have X is a set whose elements are in the form 4 to the power n minus 3 into n minus 1, where n is a natural number. Okay. So if you take different value of n, as n is a natural number, so we can take 1, 2, 3 and just substitute into the 4 to the power n minus 3n minus 1. We get a different elements for set X, that is 0, 9, 54, 243. Okay, comma dash dash dash. So these are the element for set X. So for the set Y, the definition for set Y is 9 into n minus 1, where n is a natural number. So now we take the values of different values of n, as n is a natural number. So put n is equal to 1, 2, 3. We get set Y is equal to 0, 9, 18 and 27, comma dash dash dash. So this is your set Y and this is your set X. So if you observe, for the set Y, these all are the multiple of 9. 9, then 9 into 2, 18, 9 into 3, 27. So we get multiple of 9. Okay. And also for we can see the set X, all the elements are also multiple of 9. 9, 54, 243. Okay. So these all elements must belong to set Y. It's clear that is X is a subset of Y. Why? Because each element of X is also an element of Y. So if we take union of X and Y, we get Y. Because as each element of X is also an element of Y, so when we combine this both set X and Y, we only left with Y. Okay. So union of X and Y is Y. Question number 4 is, so in this question, we are given three sets A, B and C. And we satisfy a condition that if we perform A intersection B and A intersection C, then both are equal. And if we perform A union B and A union C, then both are also equal. Now we have to tell whether A is equal to C or B is equal to C, or A intersection B is an empty set, or A is equal to B. We have to tell which option is correct. Given condition is A intersection B is equal to A intersection C and A union B is equal to A union C. So correct option is option B. Let's look at the solution. So clearly it is given that A intersection B is equal to A intersection C and A union B is equal to A union C is possible if B is equal to C. So to do this question, we can construct a Venn diagram, and when we construct a Venn diagram, it is clear that this condition is only fulfilled if B is equal to C. So correct option is option B. Okay. Now next question is question number 5. We have 30 sets A1, A2, comma dash 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 A30. Okay. and each have 5 elements. Number of element in each set A1, A2 and A30 is 5. And we have another set B1, B2 and Bn, meaning there are total n sets. And the number of element in each set is 3. Okay. Now, if we assume that union of all AIs, that is union from I from 1 equal to 30, AI is equal to union of all Bj, union of j equal to 1 to n Bj is equal to S, then this is given that you are asked to find n. What is the value of n? Okay. And the given condition is every element of S appear in exactly 10 of the AI set and exactly 9 of Bj set. So if you have an element A that belongs to the union of AIs and union of Bj, that is belongs to S, then that element, if we take it as X, then X must belong to exactly 10 of AIs, okay, and exactly 9 of Bj. That is your given condition. And now, so we have to find the value of this n, and the given options are 15, 3, 45 and none of this. So correct answer is option C. So let's look at the solution. So if you're talking about the union of all AIs, so there are total 30 sets A1, A2 and A30, and if we take the union of A1, union A2, union A3, union dot dot dot, union A30. So how many are there in total? So if we take all the sets AIs are disjoint sets, then the number of elementary in this union is 30 into 5. Okay, but as the given condition that union, if a element belongs to a union, then it belongs to exactly 10 of AIs, it says that AIs are not a disjoint set. Okay, so each element is used 10 times. That is, if X belong to S, then X must belongs to 10 different AIs, exactly 10 different AIs. So if we take the union and count the cardinality of union, we count one element 10 times. Each element is used 10 times. So the cardinality of the union is 30 into 5 by 10, that is 15. In a similar way, if you are talking about the union of set Bj, so B1 union B2 dot 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 union Bn, and these are all are also not a disjoint set, because if an element belong to that union, then it's belong to exactly 9 of Bj. Okay, so if it is disjoint, then its cardinality is 3 into n, but each element is repeated 9 times and counted only once in union. So to find the exactly what is the cardinality of the union of all Bj, we must divide it by the 9. So ns is equal to 3n by 9. Okay, so here from equation 1, 15 is equal to 3n into 9 by 9, so n is equal to 45. That is your value of n. Okay, next question is, if A and B are two sets and A union B union C is equal to U, then we are asked about what is A minus B union, B minus C union, C minus A ka whole complement. Is it equal to A union B union C, or option B A union B intersection C, or option C A intersection B intersection C, or A intersection B union C? So we'll do this question by Venn diagram. So correct option is option C. So let's look at the answer. So from Venn diagram, we can just construct a Venn diagram for all the, there is a first rectangular reason represent your universal set, then set A, B and C, and then what is A minus B? So element belongs to A but not to B, that is your A minus B, then B minus C and C minus A. When we take the union of all and its complement, it clearly visible that the answer is A intersection B intersection C. That is your answer for A minus B union B minus C union C minus A complement. Okay. So today we will cover set theory.
Hello students, so welcome to the class. Today will be our first day of this JEE 40 days crash course. The chapter will be obviously the first chapter, some basic concepts of chemistry. So first I will go with the theory part in a short time, and then after we will move on to the questions that are related to the theory that I have taught today. So most of them will be PYQs. So let's start our class. So this is our disclaimer. Now, if I talk about the analysis, so there are total of, I would say, 12 questions that were asked from 2017 to 2024, right? So I would say that at least one question has been included in each year of the JEE. So this is very, very important. Why? Because it's a small chapter and you will get sure shot one question from there. What about the weightage? So 5% is the weightage of it. So we will talk about now the proportion of topic from this chapter. If I just divide the topics, so there are three important topics. Just note it down for you. The first one is the percentage composition, okay, and the empirical formula. So this is the first important part. Remember this. Second one, the most important, the mole concept and the molar mass. So this is the second important part. And the third one is the stoichiometric calculation. So these three topics are the important topics in your chapter for some basic concepts of chemistry for today's class, right? So remember these three topics. Again, I am repeating it. Percentage composition and empirical formula. Second, mole concept and molar mass. Third, stoichiometric calculation. Got it? Now, let us see the analysis on this basis. You can see that in every year, starting from 2021 to 2024, you would see question from these three topics only. Like in 2024, you are asked a question of stoichiometric calculation of one question was there and that was of easy level. Okay. Then again, in mole concept and molar mass in the stoichiometric calculation, three questions were asked from the mole concept and all of them are of average level. Right. Moving on further. Then if I talk about the year 2017 to 2020, again you can see questions from mole concept, empirical formula and stoichiometric calculation. So overall these three topics are important for your chapter, some basic concepts of chemistry. So let us just begin with the next part, which is your first topic, mole concept and molar mass. Now what is mole concept? If I define it simply, it is the amount of substance which contains 6.022 into 10 to the power 23 particles. So this value is known as Avogadro number. So irrelevant of what thing you are taking, so it can be anything like electron, proton, neutron, or you can take a macroscopic object like apple, everything, right? So whenever you take 1 mole of that substance, it will contain 6.022 into 10 to the power 23 particles of that substance. So that is for sure. Suppose if you take 1 mole of electron, it will contain 6.022 into 10 to the power 23 number of electrons. If you take 6.022, if you take 1 mole of suppose apple, then it would contain 6.022 into 10 to the power 23 number of apples. So irrespective of the object whose mole you are taking, the count will be same, which is equals to the Avogadro's number. Now moving on to the next, why is mole important? Why do we use it? So if you have your mole, if you have the number of moles, you can calculate various things, like you can calculate the mass of the substance. If you know the number of moles of that substance, you can calculate the mass. Second thing you can calculate is your volume. So if you are dealing with gaseous substances and if you know the number of moles of that gaseous substances, you can easily calculate its volume. Third thing is the number of particles. So if you are knowing the number of moles, you can easily calculate its number of particles. Now just think about it. Suppose you are taking a table, right? Now there are millions and trillions of electrons. It is literally not possible to calculate the number of electrons. Now think from a different perspective. You know the number of moles that are present in your table, and it is easier to calculate because the formula is very simple to calculate the number of moles. It is given mass by molar mass. You know your table is made up of which material and what is the mass of it, and the material from which it is made, you can calculate its molar mass and you know it how to calculate it. So simply take the mass of the table, divide by the molar mass of the table of that substance from which the table is made, and you will get your what? You will get your number of moles of atoms present in the given table. Now further you can calculate the number of electron also. So just think about it. It's a very useful thing. Now let us look upon some handy formula which will be useful throughout your calculation. So first is, how can you calculate the number of moles if you know the mass of a substance and the molar mass of that substance? So it will be simply given mass by the molar mass. Now look on to the units. So if you just see the units, so gram and gram will get cancelled out, and finally you will get your unit of moles as mole, right? So this is also important to do the dimensional analysis so that you can look upon the credibility of a given formula. Now the next and the most important part, what? So this is the tool from which you can calculate the number of moles in a gas. Now this calculation is used exclusively in thermochemistry. Suppose you are given the volume of a gas at STP and you need the number of moles. How do you calculate it? It's very simple. Simply divide the volume of that gas at STP by 22.4 and you will get your number of moles. So here the 22.4 liter should be specifically mole per liter, and therefore the unit will get cancelled out. So liter per mole and unit will get cancelled out to give you the final thing as moles. Now what is STP? It is standard temperature and pressure. Moving on to the next, how can you calculate the number of moles if you are given the number of particles? So again you will use the unitary method here. You know it very well that 1 mole of a substance contain Na number of particles. Okay. Now you have to calculate the number of moles in a, I would say, in a random number of particles. Suppose I give you 2 electrons and ask you to calculate the number of moles. How you will calculate it? So the number of particle here is 2, which is the number of electron, and divided by the Na, which is your Avogadro constant. So what you will get? You will get your number of moles. So what about, okay, you can get your notes from our website. It is there in our website. You can simply log in, and for how to log in, you can go to our first session. Now moving on to further, if you just reuse this formula or just cross multiply it, the number of particle would be Na into moles of any particle. Okay, so this is just the reverse of what we have seen. Now next, an important part. Suppose you are given the number of moles for a given ion. So suppose 2 moles of ion is given. How do you calculate the total charge present? So it is very simple. Just multiply the number of moles with the Avogadro number, then multiply it with the charge of one ion, and then with the 1.6 into 10 to the power minus 19 coulomb. So this will give you your charge in terms of coulomb. Next is the molar mass. So what is molar mass? It is defined as the mass of 1 mole of a substance in grams. Okay, so it's very simple. Suppose I ask you that what is the molar mass of your oxygen? You will tell it that the molar mass of oxygen is 16 gram, right? Now if I ask you what is the number of particles present in that 16 gram of oxygen, you will tell that there are 6.022 into 10 to the power 23 atoms of oxygen present in 16 gram of your oxygen. So this is your application or the extended version of your molar mass thing. Got it? Now moving on further. Next we have the second important topic. So first we have covered, which is your mole concept. The second thing is percentage composition, empirical formula and molecular formula. Let's see how we can define these things. So first of all, what is percentage composition? Now this thing is similar to your percentage in examination. How do you calculate the percentage which you got in your examination? You write the marks obtained by you divided by the total marks that were in your exams and multiply it by 100 to get your percentage of the examination that you got, percentage of the marks that you got. So that is your simple formula, right? Now extend this formula to calculate the percentage composition of any element given in a compound. Now if you extend that, then the new formula to calculate the mass percentage of any element would be, so in the numerator you will write the mass of element in the compound divided by the molar mass of compound multiplied by 100. Suppose take the example of water. So just note it down with me. Suppose you are writing that what is the percentage composition of oxygen in water. So what will be your answer? It's very simple. If you take 1 mole of water, then its mass would be 18 gram, right? So 2 from hydrogen and 16 from your oxygen. So in the denominator, your molar mass of the compound would be 18. What will be in the numerator? It will be the mass of hydrogen. So there are 2 hydrogens, so that will give you 2. So 2 by 18 into 100. So this will give you your mass percentage of hydrogen present in water. Very simple. Okay, I hope you are getting this point. Now moving on to further to the empirical formula. So what is empirical formula? So to understand this empirical formula, first you should know what is simplest whole number ratio. Suppose you are taking the formula of glucose, which is C6H12O6. Then what is the common ratio between all of this? It is 6, right? So 6 is the common ratio. If you take 6 common, then what will be left? 6H2, sorry, CH2O. So this will be your empirical formula. So here what you are doing? You are just simply reducing your coefficient to a simple whole number by taking a common number outside, right? So that is the idea behind it. Got it? Now, what is the physical significance of empirical formula? So I would say nothing. Empirical formula is just the simplest whole number ratio and it has no physical resemblance. But your molecular formula is the real deal. It tells you about the exact number of atoms. Suppose you are taking glucose, then you know the molecular formula of glucose is C6H12O6. Now this will imply that your one molecule of glucose will contain 6 atoms of carbon, then 12 atoms of hydrogen and 6 atoms of oxygen. So this is the physical interpretation of your molecular formula of glucose. But if I tell you that the empirical formula of glucose is CH2O, so how do you calculate this empirical formula? So C6H12O6, you just take the 6 common out from that. So 6 from carbon gives you C1, from H12 you get H2, and from O6 you get O. Now this CH2O is the empirical formula. Now this empirical formula has no physical interpretation because your one molecule of glucose will not contain one carbon, two hydrogen and one oxygen. Hope you are getting the point. Now moving on further, how do you calculate? So if you are not getting the concept, focus on the formula that we use, right? So its formula is N is equals to molecular mass by empirical formula mass. How do you do it? What is the meaning of this? Suppose you take again the example of glucose. So first note this down, the molecular formula of glucose. It will be C6H12O6, right? So C6H12O6. How do you calculate the molecular mass of this glucose? What you will get? So try to calculate and give the answer. What will be the molecular mass of your glucose? So we are taking 6 carbons, 12 hydrogens and 6 oxygens. So that will give you the molecular mass as, anyone? So what will be the molecular mass of your glucose? It will be 180 gram per mole, right? Now next, what is the empirical formula of your say glucose? It will be CH2O. Got it? What it will be? It will be CH2O. Now if you calculate the empirical formula mass from this CH2O, what you will get? So C give you 12, then H give you 2 and O give you 16. So 12 plus 16 will give you 28 and 28 plus 2 will give you 30. How I am calculating it? Again, first take the empirical formula. How do we calculate the empirical formula? Your C6H12O6 is reduced to the simplest whole number, which is CH2O. Now you calculate the empirical formula mass, which is 12 from carbon, 2 from hydrogen and 16 from oxygen, and that will count you to a total of 30. Now 180 by 30, it will give you 6, right? So in this way you will calculate your N, which is your whole number, which you have to multiply throughout the empirical formula to get the molecular formula. Now moving on to the next, what is N here? So N will be always a integer, and that should be 1, 2 and 3, means a non-zero positive integer, right? Now moving on further, if you want to calculate the molecular formula, it would be very simple. You have to simply multiply your N with the empirical formula and you will get your molecular formula. Next, we have this vapor density. Now this vapor density term is also used sometimes. Now if I tell you about the definition of this vapor density, it would be quite complex. So the simple thing would be remembering the formula for it. How it is calculated? So it is simply calculated as molecular mass is equals to 2 into vapor density, right? Molecular mass is equals to 2 into vapor density, means molecular mass is always 2 times the vapor density. You can also calculate it from the molar mass, and since molecular mass and molar mass both have the same numerical value, only the unit is difference. Okay, now let me tell you an important difference which is between your molecular mass and molar mass. If you are talking about the numerical value, then the numerical value is same for both molecular mass and molar mass. Suppose if I tell that what is the molecular mass of your water, you will tell it that it is 18U, which is 18 unified mass, right? You use your unit for calculating molecular mass, then or AMU, 18 AMU or 18U. Then if I ask you what is the molar mass of water, you will tell that it is 18 gram per mole, means the numerical value is same. The thing which is only changing is your unit. Now this unit is telling you something. What it is telling you? It is telling you that one molecule of water has a mass of 18U, whereas this molar mass is telling you that 1 mole of water means 18 gram of water. Sorry, 6.022 into 10 to the power 23 molecules of water has a mass of 18 gram. Okay, got it? So basically what is being said here? It is said that both have the same numerical value, only the unit is changed and the concept behind it is different. Now, if the numerical value is same, you can use it to calculate the vapor density. I hope it is clear to you. Now moving on to the next important topic. Now this topic is something which is important for this chapter as well as many chapters coming in the subsequent days, like your equilibrium, or if you talk about thermodynamics, or if you talk about solutions. All of these topics need the idea of this concentration. So we will now talk about this. Sorry. Now next, it is molarity. Yes, unit is very important. While writing your answer or while mentioning your answer in your options, you should always think about the unit. Okay, so it may give you a better expect to attempt a question as well. Now moving on to the first concentration term, which is molarity. What is molarity? If I define it simply, it is the number of moles of solute per liter of solution. Okay, suppose you take any solution and if I ask you what is the molarity of that solution, how you will calculate it? You will take 1 liter of that solution and try to calculate the number of moles of solute present in that 1 liter of solution. Now the next formula which is often used is in terms of millimoles or milligram molecules. So don't get confused with this milligram molecules. It is simply a different name for writing millimoles. So how do you calculate the molarity from millimoles and milliliter? It's very simple. So it is number of millimoles of solute present per milliliter of solution. Okay. Now it is designated by capital M. Remember, it is designated by capital M. And second thing, it depends upon temperature. Now the question arises, why it is depending upon temperature? Because molarity is calculated using the volume, and volume of anything like your if you take especially your gas or if you're taking your liquid, it will depend upon the temperature. So if you change the temperature, the volume will obviously change, and hence the molarity is dependent upon temperature indirectly. Moving on further, if I try to illustrate the same with the help of an example, suppose I tell you that the molarity of H3O of a given solution of H3PO4 is 0.18. Now what it means? It means that if you take 1 liter of that 0.18 molar solution, it will contain 0.18 mole of H3PO4. Again, I am repeating it, that if you are taking 0.18 molar solution of H3PO4, it means that 1 liter of that solution will contain 0.18 mole of H3PO4. Got it? Now moving on further, we can write the formula, which is number of moles of solute divided by volume of solution in liter. So this is the formula for calculating the molarity of any given solution. Next, what we have? Next, we have the application of this molarity. What is the application? So if you take, suppose you are taking two solutions, right? If you are mixing them together, then what is the resultant formula or what is the resultant molarity? So we will solve the question. If you are having a doubt, hope we'll clear it there, right? Suppose you are taking two solutions. The first solution is having a molarity as M1 and volume as V1. The second solution is having a molarity of M2 and volume as V2. Then if I ask you, how do you calculate the new molarity after mixing these two solutions together? It will be M1 V1 plus M2 V2 by V1 plus V2. So this is an important formula to calculate the solution, the concentration of mixture formed by mixing two solutions whose molarity and volume is known to you. Next, an important thing, which is strength. So it is used sometimes in your practical chemistry. How do you calculate it? So it is simply defined as the amount of solute present in 1 liter of solution, and it is calculated as weight of solute divided by volume of solution in liter. So this weight is usually taken in terms of gram. Okay. So how do you calculate the strength? Weight of the solute in gram divided by the volume of solution in liter. Moving on further. Next we have molality. So what is molality? The number of moles of solute present in 1000 grams of solvent or 1 kg of solvent. Okay. So molarity is number of moles of solute divided by volume of solution in liter, whereas molality is number of moles of solute present in 1 kg of the solvent or 1000 grams of the solvent. So here in the denominator you are taking the amount of solvent. In the case of molarity you are taking the amount of solution. The second difference is the notation part. So molarity is denoted with the help of capital M, whereas molality is denoted with the help of small m. Now next, since we are taking the mass here, okay, we are taking the mass of the solvent and not the volume. As a result of it, it is independent of temperature. Your molality is independent of temperature. Finally, we can write the formula, which is simply moles of solute divided by the weight of solvent in grams multiplied by 1000. Now suppose if I tell you that this weight is already given in kg, so in that case you won't multiply the whole formula by 1000. You will simply take it as moles of solute divided by the weight of solvent in kg. Okay, moving on further. Next we have normality. Now this normality is something which is used in calculation in case of your redox reactions. We will do questions, extensive questions on this, so that you can grasp this important concept of normality. Okay, we'll see to it. Now how it is defined? If I define it simply, then it is the number of gram equivalents of solutes per liter of solution. So this thing is something which is related to reaction. How do you calculate it? Suppose you are taking one molecule of H2SO4, okay, and you are taking one molecule of NaOH. If you do the reaction of these two molecules, what will happen? Your one H2SO4 will give 2H plus, whereas your one NaOH will give 1 OH minus. Means your H2SO4 has a greater equivalence. It has greater number of equivalents. So all of the H2SO4 will not be neutralized because it has H plus again present in it, which is ionizable, right? So to completely neutralize one molecule of H2SO4, you have to take two molecules of NaOH. I hope you are getting the point. Okay. Now, again, we can take an example of it. For example, if you are taking 0.1 milligram of equivalent of CaO, then it will react with 0.12 gram of Na2CO3. How do you calculate it? So it is gram equivalent of solute divided by the volume of solution. Okay. Or you can write it as gram equivalent of solute divided by volume of solution in milliliter multiplied by 1000. Now last concentration term is your mole fraction. Now to calculate the mole fraction, you have to take a simple formula, which is the number of moles of the component whose mole fraction you are calculating divided by the total number of moles. So this will give you your mole fraction. Again, this is a ratio, so it will not have a unit. Means why I am saying it to neutralize, because NaOH is a base and H2SO4 is an acid, right? So if you want to do the reaction, it will act as an acid base reaction to neutralize both of them. Since your H2SO4 is giving 2 hydrogens and your NaOH is giving one hydroxide, so you will need 2 molecules of NaOH to neutralize 1 molecule of H2SO4. Now what about the mole fraction formula? How it is calculated? It is calculated as number of moles of component divided by the number of moles of the solution. Now an important conclusion here. So if you are taking a solution where there are multiple components, then how do you calculate the overall mole fraction. If you add all of them together, you will get it as 1. Now the question arises, why? Suppose you and your friend are celebrating birthday, right? And in that occasion, you brought a cake. Now four of you are there, and each of you got 1/4 of that cake. So basically, what we are taking fraction here, 1/4, 1/4, 1/4, 1/4, right? Now, if you all of your friend have taken 1/4, if you add the contribution from your each friend, then you will get your whole cake, which was your 1 unit cake. Similar to that, right? Similar to that, you have this mole fraction. So you have a gas containing a number of moles, and you are taking a fraction of that particular component. Now, if you take all the fraction of all the components present in that given mixture and add them together, you will get your whole gas, and that is the reason you are getting 1. Okay, what is gram equivalent? Question arises, what is gram equivalent? So, if I put it in simpler terms, I will explain this thing with the help of an example. Suppose you are taking sulfuric acid. What is the molecular mass of sulfuric acid? How do you calculate it? If you add the mass of 2 hydrogens, 1 sulfur and 4 oxygens. So that means 16 4s are 96. Then we have 2 hydrogens, 98. And then we have 1 sulfur, which is 32. So 96 plus 32, that will give you how much? So what will be the overall mass? Anyone? What is the molecular mass of H2SO4? How do you calculate it? So once you got it, so I'm leaving it to you. So suppose you got X as the molecular mass of your H2SO4. Then to calculate the gram equivalent, you will simply divide that molecular mass of H2SO4 by 2. Right? And in that way, you will get your gram equivalent. Got it? So basically, it is the amount of substance which is going to react. Okay, yeah. So 130 divided by 2. So that will be your equivalent weight of H2SO4 in an acid-base reaction. Got it? Now this was all for the theory part. Now we will do some questions on the same, and I will try to attempt major questions on equivalent gate. So why we are taking 2? Because one H2SO4, one molecule of H2SO4 is donating 2H plus, means it is a kind of your reactivity that is, or contribution coming from H2SO4, right? So that is the reason we are taking 2. Now this equivalent weight has different perspective depending on the reaction that we are dealing. In case of acid base reaction, we take it as the number of H plus donated or OH minus donated, right? In case of a redox reaction, we take the number of electrons that are being transferred. So this thing changes according to the reaction we are dealing with. Okay. So just wait for a while. I will just move on to questions. Then we will see questions on it. So here is your first question. You are said that 2 oxides of metal were found. Okay. Now, in those 2 oxides, the first one contains 31.6 grams of 31.6% of oxygen, and in the second one we have 48% of oxygen. Again, I am repeating it. So there are 2 oxides of metal. The first one is containing 31.6 gram of percentage of oxygen, and the second one is containing 48% of oxygen respectively. Right? Now, if the formula of the first, which is containing 31.6% of oxygen, is M2O3, So it is telling for the first metal oxide it is M2O3. Then you have to calculate the formula of the second. Simple. I hope you got the question. So this is a question which combines your mole concept, your unitary method as well as percentage composition. So let's see how we can calculate it. Now, first of all, the correct answer is MO3. To do this, first we are writing what is given in the question. We know that the first oxide is M2O3. What is the first oxide? It is M2O3. Next, in this, we have 31.6 grams of oxygen, percentage of oxygen, right? Then, what is the percentage of metal? So there are two components, oxygen and your metal. So if one is 31.6, the second one will be obviously 68.4. So addition of both will give you 100%. So this is very obvious. Then we are supposing that the second metal oxide is MXOY. Okay. Now if it is MXOY, then in this case your oxygen percentage is given as 48%. Therefore your metal percentage will be 52%. Right. So what can we say from here? Anyone? You get my point? So we are saying that for the first metal oxide, the percentage is 68.4. What does it mean? It means that for the first metal oxide, 100 gram of that metal oxide contains 68.4 grams of metal and 31.6 grams of oxygen. Clear? Again I am repeating it. The percentage means that 100 gram of that first metal oxide contains 68.4 grams of metal and 31.6 grams of oxygen. Now, next what we can say, that since the formula for the oxide is M2O3, that means that 68.4 grams of metal will contain 2 atoms of metal, right? Is it clear to you? You are getting my point? What we can say is that 68.4 gram of metal in first oxide will contain 2 atoms of metal. Now, if that is true, then we can calculate 52 grams of metal what it will contain. So we will simply use the unitary method, which is 2 into 52 divided by 68.4, which is 1.5 atoms of metal. Now, next what we will do? We will do the same for oxygen. We know that 31.6% of oxygen is present. Now, from the molecular formula, which is M2O3, we can say that 31.6 gram of oxygen in the first oxide will contain 3 atoms of oxygen. Right? Now, again applying the unitary method, we can say that 42 gram of oxygen will contain 3 into 48 by 31.6, which is 4.5 atoms of oxygen. Now, complying this both, we can take the simple ratio and write it as 1:3. Therefore, the molecular formula will be MOO3 for the second oxide. So again, I am repeating it. So we start with the thing which is given already in the question. We are given with the oxide of first formula for first oxide, which is M2O3, and its percentage is also given, which is 31.6% and 68.4%. Now from the percentage, we know that 68.4 gram of metal will contain 2 atoms of metal. Therefore, 52 gram will contain 2 into 52 by 68.4. Similarly, we can do it for oxygen, and hence we will get MO3 as the final formula. So this was all for the chemistry part. So we will try to solve questions on equivalence on the next day. Our next faculty will join you in a minute.
Hello students, in today's lecture we are going to learn about units and measurements. This is our disclaimer. Let's see the trend analysis JEE main. The chapter is units and measurement. So the overall weightage is 4.24%. And if we talk about the yearly question distribution, so in 2024, the question asked from dimensions of physical quantity and concept covered dimensional formula. Number of questions 1, and if we talk about the difficulty level, that is easy. Alright, and here key focus area is basic dimensional formulas of physical quantities. Similarly, we can say in 2023, 2022, 2021 and 2020, the question asked from errors in measurements, dimensions of physical quantity, and their difficulty level is average, difficult, average respectively. Alright. So in today's lecture we will cover units, then fundamental and derived units, after that system of units. Alright. So units. Measurement of any physical quantity involves comparison with a certain basic widely accepted reference standard called unit, meaning that to measure any physical quantity such as length, mass, time, we compare it with a basic internationally accepted reference standard which is called a unit. For example, if we say that the length of an object is 5 meters, then meter here is a unit, and we are comparing the length that object with the meter. Fundamental and derived units, this is very important. If we talk about the fundamental units, so we can say these are units that cannot be formed from any other unit. They are the units of fundamental quantities, or in other words, base quantities. They are the independent and cannot be expressed in terms of any other physical quantity. Fundamental quantity is independent of any other physical quantity. However, derived units are the units of the measurement of all physical quantities which can be obtained from fundamental units. So if we talk about the example, so we can say speed, volume, force. So these are the derived units from base quantities. System of units. A complete set of units which includes both fundamental and derived which are formed from fundamental units, types of units, is called a system of units. These systems have been developed to bring consistency and accuracy in measurement. Common systems are as follows. First, CGA system. So if we talk about the CGA system, we can say length is measured in centimeter, alright, and mass is measured in gram, time in second. This is a metric system used in science specifically for the measurement of small objects and distances. Second is FPS system, also known as British unit system. So in this system, we can say foot, pound and second. So length is measured in foot and pound, means mass is measured in pound and time is measured in seconds. And third is MKS system. So in MKS system, length, mass and time have been taken as a fundamental quantities and corresponding fundamental units are meter, kilogram and second. Clear? And fourth one, and very important, SI units. International System of Units is an extended version of the meter, kilogram, seconds. All right, extended version, MKS system. So it includes 7 base units: meter, kilogram, second, ampere, Kelvin, mole, candela, and there is a 2 more units, that is supplementary units. So radian for angle and steradian for solid angle, which use quantities for their definition, so that scientifically we can say globally accepted. So here we have some base quantities: length, mass and time. So length measured in meter, mass measured in kilogram and time measured in second. Clear? And other base quantities: electric current, we can say measured in ampere. So ampere is that constant current which if maintained in two straight parallel conductors of infinite length and placed 1 meter apart from each other in vacuum, so will produce a force of 2 into 10 raised to the power minus 7 Newton per meter on each conductor. And another base quantity is uh, Kelvin, or we can say thermodynamic temperature, and the unit is Kelvin. And last one, amount of substance, base quantity, and their unit is mole. So we can say mole is that quantity of any substance that contains as many elementary entities such as atoms, molecules, ions, etc., as there are atoms found in 0.012 kilogram of carbon 12. Clear? Now, third one, last one, luminous intensity measured in candela. So, luminous intensity is measured in candela. This means that candela describes the luminous intensity of a light source at a particular direction. So, according to the definition of candela, one candela is the luminous intensity where monochromatic radiation emitted from a source light of a single frequency has a frequency of 540 into 10 raised to the power 12 hertz, and its radiant intensity in the particular direction is 1 divided by 683 watt per steradian. Alright, in simple terms we can say this is a standard way to describe how much light a source is emitting in a specific direction. Now we will talk about the supplementary units. So here we know we have a two supplementary units. First plane angle, second solid angle. So if we talk about the plane angle, so we can say plane angle is measured in radians, which is subtended at the center of a circle when the length of an arc is equal to the radius of the circle, whereas solid angle is measured in steradians. It is a we can say it is a solid angle subtended at the center of a sphere covering an area on the surface of the sphere to the square of its radius. All right. Now we will discuss about the significant figures. Students, now we will learn second part of units and measurements. This is our disclaimer. So here we will cover significant figures, rules for counting significant figures, rules for arithmetic operations with significant figures, and rules for rounding of the uncertain digits. Then accuracy and precision. After that, least count, then errors in measurement and combination of errors, dimensions of physical quantities, principle of homogeneity of dimensions and applications, uses of dimensions, and last, dimensions of important physical quantities. So these are the topics which we will cover now. So significant figures. So if we talk about the significant figures, we can say significant figures refer to all the digits in a measurement that are considered reliable, along with the last digit which may be somewhat doubtful. Let's understand this with an example. Clear? So suppose you measured the length of an object as 25.3 centimeter using a ruler. In this measurement, 2 and 5 are absolutely certain. We are completely sure about them. However, we are not entirely sure about the last digit 3. So it is possible that the actual measurement might be 25.2 centimeter or 25.4 centimeter, but our eyes estimated it as 25.3 centimeter. So in this case, the reliable digits 2, 3 and 5 and the doubtful digit 3. So combine to give a total of 3 significant figures. This means we can say that the significant figures tells us about the precision of any measurement. The more significant figures there are, the more precise of the measurement. Clear? So in any measurement, the more significant figures there are, the higher its accuracy will be. So this is because more significant figures mean that the measurement tool is more precise, which reduces uncertainty. Now let's see rules for counting significant figures, and this is very important for the exam. So let's now study rules for counting significant figures. Whenever we count significant figures, there is a basic rule that all non-zero digits are always significant. This means that all digits from 1 to 9 are counted. So according to this rule, in the numbers 2.738, all digits 2, 7, 3, 8 are non-zero. So therefore, every digit here in first line, every digits are significant. So there is a total 4 significant figures. Alright. So if we talk about the second rule, so we can say all the zeros between two non-zero digits are significant, no matter where the decimal point is. So as example, suppose 209. So here 0 is between 2 and 3. So this we considered here 0 as a significant. Similarly 3.002. So here 0 is between between two non-zero digits. So here we can say in 3.002 have a 4 significant figures and 209 have a 3 significant figures. If the measured number is less than 1, alright, the zeros on the right of the decimal point and to the left of the first non-zero digit are non-significant. Suppose we have a number, suppose 0.00807, okay? First 3 digit zeros are non-significant, alright, it means 0.00 are non-significant, and the numbers are only significant figure is 3. So the terminal or trailing zeros in a number without a decimal point are non-significant. Suppose 12.3 meter is equal to 1230 centimeter and 12300 mm. So there is only three significant figures. All right. So in this number, suppose in this number, 12300, we have a one more digit like 0. So we can say again there is only three significant figures. All right. The trailing zeros in the number with a decimal point are significant. Thus, 3.800 kg has four significant figures. So, a choice of change of units does not change the number of significant digits or figures in a measurement. So, as a conclusion, we can say if the unit, suppose meter to centimeter, centimeter to mm, so significant figures remain same. It does not change. Now, we will look at some more rules regarding significant figures. So, for instance, we just saw that when we write a measurement, we measure it in meters, centimeters, millimeters. So, the method of writing is different. There is a standard method which we call scientific notation. When we write a scientific notation, it is something like this: a into 10 raised to the power b, where a can be any number between 1 and 10. It can be anything. It can also be a decimal, and here we only need to write significant figures. So only significant figures are, the rest is 10 to the power b, where b is the order of the magnitude. All right, and here it represents the order of the magnitude. So as you might have been have seen, 9.1 into 10 raised to the power minus 31 kilogram, it is written like this. So 9.1 is a and minus 31 is b. Clear? All right. When performing addition or subtraction, the final answer should have as many decimal places as the number with the fewest decimal places among the original numbers. So this indicates that your answer can only be as accurate as the least precise measurement. So when we add or subtract measurements, the final answer should have as many decimal places as the number with the fewest decimal places among the original numbers. So let's understand with an example. Clear? So listen carefully. So numbers 423.5 G and 164.92 G and 24.381 G. So to understand this, first let's count the decimal places. So 42.5 G has one decimal place, 164.92 G has two decimal places and 24.381 G has three decimal places. So the fewest decimal places are in 423.5 G, only one. Yes or no? Therefore, your final answer should also be to one decimal place. The total sum is 612.801 G. So rounding this to one decimal place, the answer will be 612.8 G. Therefore, 612.8 G is the correct answer. All right. So when we multiply or divide, suppose next rule is when we multiply or divide two or more numbers, the final answer should have as many significant figures as the number with the fewest significant figures among the original numbers. So let's understand with an example. All right. So suppose we have a number. Listen carefully, everyone. So here 243 into 1243 divided by 44.65. Yes or no? Is equal to 6764.81522. So first let's count the numbers and their significant figures. So 243 has 3 significant figures and 1243 has 4 significant figures and 44.65 there is a 4 significant figures. So the fewest significant figures are with 243 which is 3. So the exact answer of calculation is 6764.81522. Clear? So according to the rule, we need to round this to 3 significant figures. The first 3 significant figures are 6, 7 and 6. After this is 4 which is less than 5. Therefore, round down. So rounding of 6764.81522 to 3 significant figures, the answer will be 6760. Here 0 is a placeholder, it is not a significant. Alright. When you round off a number, you look at its insignificant digits, the digit to be removed. So if the insignificant digit is greater than 5, for like 6, 7, 8, 9, then the preceding digit is increased by 1. Alright, so if we talk about an example, so in 18.764 you need to remove 6 which is greater than 5. Therefore 7 is increased to 8. The number becomes 18.8. If the insignificant digit is less than 5 like 4, 3, 2, 1, then the preceding digit is not changed at all. Let's see an example. So in 18.74 you need to remove 4 which is less than 5. If the insignificant digit is exactly 5, then usually the preceding digit is increased by 1. Alright. So if we talk about an example, so 18.75 is rounded off to 18.8. When let's see next rule, when rounding of a number and the last digit is 5, then the preceding digit is observed. So let's understand this in 2 cases. So case first, the preceding digit is even. Alright, if the digit preceding is even like 0, 2, 4, 6, 8, then 5 is simply dropped. Alright, and in here 17.845 needs to be rounded off. So here the insignificant digit is 5. The digit preceding is 4 which is an even number. So 5 will be dropped and the number will become 17.84. Let's see case 2. So the preceding digit is odd. Alright. So if the digit preceding 5 is odd like 1, 3, 5, 7, 9, then the odd digit is increased by 1 to make it even. If we talk about example, so we can say 17.875 needs to be rounded off. So here the insignificant digit is 5. The digit preceding is 7 which is odd, so 7 will be increased by 1 to 8. Therefore the number will be 17.88. Clear? Accuracy and precision. So if we talk about the accuracy, so we can say accuracy refers to how close your measured value is to the true value or correct value. In simple terms, it indicates correctness. Or if we talk about the true value, so the true value that should actually exist. For example, suppose the actual length of a ruler is 30 centimeter. This is that is true value. If you measure it and state 29.9 centimeter, then your measurement is quite accurate because it is very close to the true value. Whereas if we talk about the precision, so precision means how similar or close results you obtain when measuring the same quantity repeatedly. It demonstrates consistency or repeatedly. Alright. Now least count. Least count refers to the smallest and most accurate value that can be measured by any measuring instrument. It indicates the precision of the instrument. So let's understand in simple terms. Every measurement tool has some markings. Alright. So least count is the value of the smallest division or mark that you can directly read from the instrument. Let's see an example. So a normal ruler or scale. So on this, the smallest division is 1 millimeter. This means that the least count of this scale is 1 mm. You cannot accurately measure small values like 0.5 mm or 0.25 mm with it. If we talk about the more examples, we can say vernier caliper, screw gauge. So first, let's see least count of vernier calipers. So this is a more accurate tool. Its least count is usually 0.1 mm or 0.02 mm. This means that it can provide 10 to 50 times more precise measurements than a normal ruler. The method to calculate the least count uh, depends on the instrument. For vernier caliper, the formula for least count is LC equal to value of 1 mil scale division divided by total number of vernier scale division. Second, screw gauge. So this is an even more precise instrument which is used to measure very small things. Alright, like the thickness of a wire. Its least count can be add up to 0.01 mm. For screw gauge, the formula for least count is LC equal to value of one pitch scale reading divided by total number of head scale division. So lower least count is equal to higher precision. The lower the least count of an instrument, the more precise the measurement will be. Errors in measurements. So in measurements, error means the difference between your measured value, the value you have measured, and the true value, or we can say real value. So let's understand different types of errors. The first, absolute error. So if we talk about the absolute error, so we can say this is the direct difference between the measured value and the true value, whether it is negative or positive. The value of absolute error is always positive. So suppose therefore a mean, firstly we calculate the a mean value of given data. So a mean equal to a naught is equal to a1 plus a2 plus a3 plus so on, an divided by n. So here delta a1 is equal to mean value minus observed value. So delta a1 is equal to a naught minus a1. a1 is the observed value. Similarly, delta a2 is equal to a naught minus a2. Alright. And if we talk about delta an, so we can say a naught minus an. So here observed value is an and mean value is a naught. Second type of error is mean absolute error. So if we talk about the mean absolute error is a way to calculate the average error. It indicates how much your readings or measurements differ on average from their actual value. So a delta a mean is equal to mod of delta 1 plus mod of delta a2 plus mod of delta a3 plus so on mod of delta an divided by n. So this is called the mean absolute error or average absolute error. Clear? So simply we can write it like this, delta A mean equal to summation I equal to 1 to n mod of delta AI divided by n. Third is relative or fractional error. So when we make a measurement, there is a possibility of some error. Absolute error only tells us about the magnitude of the error, such as an error of 5 grams or 10 centimeters. However, to understand the importance of that error, we need to compare it with original value. So relative error indicates how large the error is compared to the original value. So to calculate this, the absolute error is divided by the true value. So relative error is equal to delta A mean divided by A mean. Fourth one is percentage error. So this is a method that shows how much an estimated or measured value differs from true or actual value in percentage. So delta A is equal to relative error into percentage error. 100% is equal to delta A mean divided by A mean into 100%. So this is the formula. Alright. This is the formula to calculate the mean fractional error, percentage error, mean absolute error. So for the exam, these formulas are very important. Listen carefully everyone. These formulas are very important. Combination of errors. When we combine measurements using different mathematical operations such as addition, subtraction, multiplication, division, so their errors also combine. So this process is called combination of errors or propagation of errors. When two quantities A and B are added to form a new quantity X, so the error delta X is equal to A plus B. Their errors delta A and delta B also combine. The rule for combination of errors is that the maximum possible error. So delta X is always equal to the sum of individual errors, delta A and delta B. This means that error never subtract but always add up. Clear? Which increase the overall uncertainty. The reason for this is what you add two measurements, their errors can be the same direction plus or minus with minus or in opposite directions as well. Similarly, if x is equal to abc, then delta x divided by x is equal to plus minus delta a divided by a plus delta b divided by b plus delta c divided by c. Basically, errors add up. If there are errors in A, B, C, then the worst case scenario. All these errors add up in the same direction, either all positive or negative, making the final error maximum. Therefore, the plus minus sign indicates the final relative error can be either positive or negative, and its maximum value is equal to the sum of these individual relative errors. And third one is if delta if x is equal to a raised to the power k into b raised to the power l into c raised to the power n, then delta x divided by x is equal to plus minus k into delta a divided by a plus l into delta b divided by b plus n into delta c divided by c. These are the fractional errors in ABC and alright. So the maximum fractional error in x is equal to the sum of the fractional errors of the individual quantities multiplied by the respective powers k, l, n. This formula shows that the errors add up in multiplication, division and powers. So here plus minus sign means that the final error can be positive or negative. Dimensions of physical quantities. So the dimensions of physical quantities are the powers to which the fundamental base quantities are raised to represent that quantity. So consider the physical quantities force. So if we talk about the force, so their dimensional formula is ml t raised to the power minus 2. Dimensions of physical quantity do not depend on its magnitude, the units in which it measured. So according to the principle of homogeneity, a correct dimensional equation must be homogeneous. So that is, dimensions of all the terms in a physical expression must be same. LHS is equal to RHS. It means the dimension formula of LHS side is equal to dimension formula of RHS side. So here now we will learn uses of dimensions. So first use is to check the correctness of a given physical equation. Second, derivation of formula. Third, dimension formula is useful to convert the value of a physical quantity from one system to other. And to express any physical quantity, we use two things. First, numerical value, and second, unit. So physical quantity uh, of any physical quantity we can write here with the use of with the help of unit and their magnitude. So in any system of measurement, this product remains constant. So let the dimension formula of given physical quantity be MA, LB and TC. If in a system having base units M1, L1, T1, the numerical value of given quantity be N1 and numerical value N2 in another units having the base units M2, L2, T2, then Q equal to N1 U1 equal to N2 U2. So this formula Q equal to N1 U1 is equal to N2 U2 is important. So we have Q equal to N1 U1 equal to N2 U2. So this formula is used in physics for units and measurements. Its main principle is that the magnitude of any physical quantity Q remains constant even if the units change. So here just put the value N1 M1 raised to the power A into L1 raised to the power B, T1 raised to the power C is equal to N2, M2 raised to the power A, L2 raised to the power B and T2 raised to the power C. Solving this, you will be get this one, N2 equal to N1 into M1 divided by M2 whole power A into L1 divided by L2 whole power B and T1 divided by T2 whole power C. And these are the some physical quantities, their SI units and dimension formula. Power, second is pressure, stress, coefficient of elasticity, and frequency, angular momentum, torque and gravitational constant. Next is moment of inertia, acceleration, force, linear momentum, work energy, kinetic energy, potential energy, surface area. All right. So you need to remember these dimension formulas. So uh, note down and take a screenshot. Similarly, electric conductivity and latent heat of vaporization, coefficient of thermal conductivity, electric voltage, magnetization, magnetic induction, Planck's constant, radioactive decay constant and binding energy. Their SI units and dimension formula. Alright. So please note down all. Now we will solve some questions based on these topics. Some practice questions based on units and measurements. This is our disclaimer. So, practice question 1st to 8th. Question is, in which of the following system of units a Weber is the unit of magnetic flux? So, please solve this question. The given options A is CGS system, option B MKS system, option C SI system and option D FPS system. Which one? Please answer. So, correct option is C. Weber is a unit of magnetic flux in SI system. So, if we talk about the symbol, so we can set capital W and small v. In an experiment, the angles are required to be measured using an instrument. So 29 divisions of the main scale exactly coincide with the 30 divisions of the vernier scale. If the smallest division of the main scale is a half a degree, that is 0.5, then the least count of the instrument is what? Please solve this question. One minute, half minute, 1 degree and half degree. So correct option is A. So we know LC equal to 1 MSD minus 1 VSD. So the problem states that 29 divisions of main scale coincide with 30 divisions of vernier scale, or we can say VSD. So this relationship can be expressed 30 VSD is equal to 29 MSD. So to find the value of a single VSD in terms of MSD, we can write 1 VSD equal to 29 divided by 30 MSD. So substitute the value of 1 VSD, you will be get the correct answer. So 1 MSD minus 29 divided by MSD. So 1 minus 29 divided by 30 MSD. So solving this, you will be get LC equal to 1 by 30 MSD. LC equal to 1 by 30, put the value of MSD, that is 0.5. So solve it, you will be get 0.5 divided by 30. So LC equal to 1 by 2 divided by 30. So it will be 1 by 60, approx 1 minute. Clear?